For Chapter 11, we're going to go ahead and get back into the quadratic equations, but we're going to be dealing with ones that are a little more complex. So on this one, we're going to just be solving quadratic equations using inverse operations. We're going to start with a recap of something you should know. If we have ax squared plus bx plus c equals 0, that is called standard form. And really the easiest way to solve these is if they can be factored. Basically, we factor this and we end up with kind of a d and an f. We know that d times f multiplies to make c. So basically c is equal to whatever d times f is. And that the middle term is the sum of those two numbers, d plus f, gives us the b. Okay? So this is kind of how we've set this up in the past. Maybe that's more complicated than we need. But the idea is that we can factor it, we set it equal to 0, and then we solve it. That will always be our easiest approach, but some don't factor. So like, for instance, here's an easy one, x squared equals 16. This one could be factored, but I can also just solve it using inverse operations. And here's how I know. X is being squared. If I look at the idea of order of operations, that squaring is an exponent. And the inverse of an exponent is a root. So a second exponent can be undone with a second root. So people are like, sweet, square root of 16, x is 4. Not quite. If you do this, you will be getting half credit for these questions. And here's why. When we put the square root in the question, then we have to consider two answers, a positive 4 and a negative 4, or we get a plus or minus. We get two answers, positive 4 and negative 4. Another way of seeing this, if you had set that equal to 0, let me scoot this over. If you had set that at 1 equal to 0, so if you'd set x squared minus 16 equal to 0, that would factor. X times x is x squared. What multiplies to make that 16 would be a 4 and a negative 4. So our answers would be what? Negative 4 and positive 4. So we got to get two answers out of that. Okay? But see, this next one, p squared equals 7, does not factor. If I try to set that equal to 0, p squared minus 7 equals 0, and we're stuck. That doesn't factor. But I can solve it algebraically, meaning I can undo the squaring by square rooting. If I do it to one side, we do it to the other. The square root of p squared is just p. The square root of 7 doesn't simplify, so we just leave it as the square root of 7. What you do have to remember is what? We put the square root in there, which means we must consider both positive and negative root 7 as our possible answers. Let's keep going. X squared minus 12 equals 0. This doesn't factor. There's no nice numbers that times itself makes 12 and combines to make 0, so what do? Well, x is being squared and it's being added. So it's being subtracted. So I undo the subtracting with adding first. X squared now equals 12. And I undo the exponent with a root. X is equal to, the square root of 12 needs to be simplified. How about 4 and 3? 2 and 2 and 3. So what comes out is a 2. What's left inside is the root 3. So what's our answer ultimately? Well, we get a negative 2 root 3 and a positive 2 root 3. Or if you'd like to put a plus or minus in front of it, I'm fine with that. The homework will have you list them separately. Either way, it doesn't bother me. Just make sure you understand. We get that plus or minus from the square root. Next one is similar, except it's being squared, multiplied, then subtracted. So now I'm adding multiplication into the mix. So I start by undoing the subtracting by adding. Working our way up, I undo the multiplying by dividing. I believe that is, what, 18? And then we undo the exponent by rooting. X is equal to, about 9 times 2, 3 times 3 times 2, out comes a pair of 3's. So that square root of 9 is 3 with a root 2 left in there. Do not forget the plus or minus. In your homework, they'll have you list that separately as a set. Negative 3, root 2, positive 3, root 2. We're also going to have some word questions. Don't freak out, they're not that complicated. When they give you the word questions, they're generally going to either give you the formula, or if it's one that you're expected to know and you don't, go ahead and hit the little help me button and they'll give you the formula. So this is basically how we relate distance over time. We have d is the distance in feet, t is the time in seconds, okay? And what we can do is we can figure out how long it takes for something to fall. So if I was standing on a building 180 feet tall and I dropped an object, how long would it take for that object to hit the ground? That's what we're figuring out here, right? So they give me the d, the distance in feet from the ground. So I fill that in. 180 is equal to 16 t squared. Solve for the time that it takes for the object to hit the ground. Well, inverse operations again. We undo the multiplying by dividing. This isn't looking pretty. How about, let's reduce that by 4. That would be what, 45 over 4? And then we're going to square root that. So we got the square root of 45 over 4 gives me the square root of 45 over the square root of 4, which is 2, plus or minus. Now let's be clear. Now I'm going to need to check this with a calculator. I think I have a calculator in here somewhere. Because you're not going to tell somebody, oh, the amount of time it's going to take you is the square root of 45 over 2. That is not helpful, right? So what we do is we're going to take that square root of 45 over 2, put it in the calculator, and we're going to get an approximate answer. Okay? So let's do that. Maybe. Anytime. So what do we say? The square root of 45. All divided by 2. So about 3.354 seconds. Or negative 3.354. See, algebraically we got plus or minus. But in the context of the word question, what makes sense? Are we going to basically have the ball hit the ground 3 seconds ago or 3 seconds after we drop it, right? So this is what we would call an extraneous solution. It's one that we get algebraically, but when I apply it to the context of the question, it doesn't make sense. So this would be the approximate amount of time till the object hits the ground. A couple more examples. The key here is do not distribute this. You're like, well, why not? Well, we'll see. But see, I don't have to distribute this. I see this x plus 3 is happening inside parentheses and then the exponent. I can deal with that exponent without distributing it all. I can undo the square by square rooting it and get x plus 3 is equal to, what's the square root of 16? Now before you keep going and subtract the 3 and get plus or minus 1, that would not be correct. You have to remember that when we put the square root, we have to get the plus or minus. That comes right now from the square root. That square root we put in the question, so that means we put the plus or minus in the problem. Our last step here is to now undo the adding 3 by subtracting, so that we get x is equal to 4 minus 3, and x is equal to negative 4 minus 3. Notice it is not plus or minus 1. The plus or minus didn't happen at the end. It happens wherever we put the square root. We have to consider a plus or minus. So we have plus 1 and minus 7. That means if I was to distribute all this out, I would end up with x squared plus 6x, plus 9 minus 16 would be minus 7. This could have factored. X plus 7, x minus 1, and I would have got back to those answers by setting it equal to 0. Well, that's great. This next one will not factor. So if you distribute and you get lucky and it's factorable, awesome. If it doesn't, we do not want to have to solve this in another way. This is really the easiest way. We undo the squaring by square rooting both sides. We're left with x plus 1 on the left side. On the right side, the square root of 6. How about plus or minus square root of 6? And last, we get x is equal to negative 1 plus or minus the square root of 6. Once again, your homework would have you list that as what? Two solutions, negative 1 plus root 6 and negative 1 minus root 6. So that would be your set of solutions. First, undo the root, undo the exponent with the root, okay? So when we put that root, it cancels the left side, 2x minus 3 equals square root of 18. We get a plus or minus. You have to simplify square root of 18. 9 times 2, 3 times 3 times 2, therefore 3 root 2. Now we add the 3. Be careful. 3 root 2 plus 3 does not simplify, so we just leave it as 3 plus or minus 3 root 2. Last, we undo the multiplying by, and we get x is equal to 3 plus or minus 3 root 2 all over 2. See, somebody else is going to take this and run this whole sucker through the quadratic formula. They're going to distribute this out, get, what would it be, 4x squared minus 12x plus 9 minus 18. We'd end up with minus 9. And it's not factorable, so they're going to run this through the whole x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. They've already had to distribute this, set it equal to 0, then fill in this formula. At the very end, if you do that correctly, you can get that answer. But that is way more work. See, if it's already in this form, or was it this form, basically it's ready for inverse operations. So don't make it more complicated. This next one especially, I would not want to run this through the quadratic formula. Why not? Well, we're going to square root this. What's the square root of negative 100? Well, we've done this before, right? The square root of 100 is just 10. The square root of a negative is? This ends up giving me negative 1 times 100, or negative 1 times 10 times 10. The square root of negative 1 is I. The square root of 100 is 10. So we have just 10i. Sort of. You got to be careful. What did we just put there? We put a square root. Do not forget plus or minus. How do I solve for k now? Undo the adding by subtracting, so that k is equal to negative 5 plus or minus 10i. You do not want to have to run that whole thing through the quadratic formula. That is way more work than is necessary. Yes, I'm glad that you know that formula. That's going to make your life easier in the upcoming sections. No, we are not using it yet. It's not practical yet. We will get in the next section. We have a method that we're going to use. It's actually going to make most of the quadratics simplified pretty easily. And at that point, if it's still more complicated, then we'll use the quadratic formula. So it's good that you know it, but just be patient. We'll get to it. There's a time and a place to use it. Now is not that time. Here's a very simple one. How do we undo squaring? X is equal to the square root of negative 17. I cannot simplify 17, but I can simplify that. What comes out? I root 17. do not put the I at the end. I understand it's tempting because it looks like a variable, but a lot of people, if you put that I at the end, it looks like the I is inside the square root. So it's a bad habit. We put the I at the beginning here. What am I missing? We put a square root, we put a plus or minus. So that in your homework, x will equal the set of numbers, negative I root 17 and positive I root 17. And that's it for this section. So starts off pretty easy. We're going to be kicking it up. The next section should be a lot newer for a lot of you. This section should be pretty much review. Kick it into gear. Chapter 11 should be a good chapter.